I'm Paul von Zielbauer, and this is Aging with Strength. Today's conversation is with Herman Pontzer, a professor of evolutionary anthropology and global health at Duke University. His research has influenced our understanding of human diet, exercise, and metabolism, and the importance of moving our bodies. Dr. Pontzer's latest book explores how our bodies function in detail and what we can do to help them work better for longer. Herman Pontzer, thanks for being on Aging with Strength.
Thanks for having me.
I'm going to talk to you about a lot of different subjects today, including the role of epigenetics, meaning how genes are expressed and how our parents and grandparents and their experiences in life may affect how our bodies work, and also other things like DNA being destiny or not being destiny in terms of how our bodies age and how we can increase our health span. And there are a couple of other subjects that I want to get into, including one that you mentioned in your book, heritability, and what traits are heritable more than others, as well as a couple of different anecdotes in your book about the Hadza tribe, and a hunter-gatherer tribe, I believe, in northern Tanzania that you studied first person on the ground, and also an anecdote about English trained conductors and English trained drivers, and what that study showed about the importance of moving your body. So I'd like to start though with your book. It's called Adaptable, but if I may read, the subtitle of your book is How Our Unique Body Really Works and Why Our Biology Unites Us. So you added that word really in there on purpose because you didn't have to have that in that sentence, but why did you put that really in there? And what's the biggest misconception, Herman, that you think people tend to have about their bodies?
Yeah, thanks for having me to talk about this stuff. I think it's so important right now. And the reason I wrote this book and put that in the subtitle, how our bodies really work, is that having taught, college level physiology, human physiology for the past 20 some years, having been doing research in this for a career now, I am reminded every day how little people know about how our bodies work. So that's the goal of the book, is to give us all a fluency in that. So I really wanted to share that. So that's why that title is what it is.
Are there sort of the top one or two assumptions that are hurting people because they think something that isn't true, or vice versa?
Yeah, so I would say that we know how our bodies work in the same way that, I had a 20-year-old car for a while. But if you ask me, do I understand how the engine works? That's a different question. And so I think, the influencer sphere is full of wrong stories about how diet works, right? People are sold this idea that your digestion can only take a very limited kind of food and it has to be this kind of diet or else, we're told stories about what natural diets look like. Exercise has to be one particular thing, and we're sold on a particular exercise program. Things like IQ, how does your brain work? We're told, when you're born, your IQ is determined by your genes, right? And there's nothing you can do about that. There's people who really believe that and push that idea. That completely countermands the way that we know brains work, the way that we know how they work. And so I think in almost every system of our body, probably some more than others, but especially in these big important issues like health and diet and my God, immune systems, right? Think about how people are talking about vaccines these days.
Right.
None of that has anything to do with how bodies work. One of my favorite one is people holding up a sign, my body is mRNA free. They're talking about the mRNA vaccines. If your body was mRNA free, you'd be dead, right? Yeah. So these kind of things. I think every part of our body has a story in there that people, maybe they know, but I would bet most of them are news stories to a lot of people.
Right. Yeah. Well, I read your book's very readable. You're not a medical doctor, but evolutionary anthropologist, and you tackle a lot of very science technical subjects in a way that I thought was very readable for people. And that's why I wanted to have you on, because you tackle so many different subjects, one of which is epigenetics. And I wanted to ask you about that because when we were kids, we never thought of the way we are may be influenced by what happened to not only our parents, but our grandparents. So could you just briefly describe what epigenetics refers to?
Sure. So people are probably familiar with the idea that they've got a set of genes that they inherited from mom and dad, the DNA that they got. That is their DNA, their unique DNA profile, and that's all the genes you have and all the variations of the different genes you have. But that doesn't mean that the genes that you're born with are all going to be sort of equally expressed. And instead, what happens is DNA is this sort of long thread-like molecule there are different sections of it that are genes that are functional that make a protein or turn things on and off. Your body, your genome, this DNA system can basically flag or mark different sections of your DNA. And that will either make those genes be more expressed or more often make them less expressed. Different parts of your DNA get often turned off with these epigenetic marks. And it's called epigenetic because it's on top of your genes, epigenetic. Now, it turns out that these epigenetic changes are a really important way that your body determines which genes are on and which genes are off. Because you've got 20,000 some genes, even more genes that are sort of regulatory, turning those genes on and off. Well, you don't have them all on all the time, right? You have some of them on in some cells, some of them on in other cells, some on some parts of the day, other parts of the day. So what determines which get turned on and turned off? A big piece of that is these epigenetic marks that either quiet these genes down or maybe in some cases can amplify them.
And so this is where it's fascinating because that's like, physical things in your body doing mechanical stuff, it seems to me. But what epigenetics says is that experiences, things that my dad or mom heard, saw, experienced when they were children, or frankly, anytime before I guess I was born, if that's true, those things, those environmental inputs into their heads and their bodies and their minds may impact how my genes are expressed. Is that right?
That's right. So your genome is a word we use to refer to all the genes you have, all your DNA. And you think of that like a big thick book, like a phone book or something like that, right? Lots of pages, lots of entries, and those are all your DNA and all your genes. Epigenetics are like little flags, little Post-it notes that we put in there that say, oh, make sure you turn this one on. Oh, make sure you don't turn this one on, right? And so those flags kind of stick with you. They accumulate, just like if you got a new book and over time you keep on putting Post-it notes in. Over time, those flags are going to accumulate, and they will change. So they actually change the way your genes are sort of activating or not activating over the course of your life, and you accumulate these marks. Now, what's really cool about this, and as the way you started this off is exactly right. We used to think that when a kid was born, they were born with a fresh slate, a clean book, no marks, no Post-it notes in that book. That's what we used to think. Turns out, probably that's not the case, and probably, in fact, the DNA that you're inheriting from mom and dad incorporates some of those flags. It comes sort of pre-flagged. So a baby's born with a book that's already marked. And they're marked by my mom and dad's experiences. Because just as you're going to accumulate those marks as you grow up, it turns out you pass some of those on. And those sort of transgenerational, mother to kid, and even maybe mother to kid to grandkid, that epigenetics information gets passed along. Those Post-it notes keep going. And we're only now beginning to understand what effects those have, but they seem to be really important.
So this is utterly fascinating, and it seems like epigenetics is just getting started as a vertical, as a scientific vertical. Maybe it's been around, maybe not. Well, but
so I'll say this: in mice we can do this really well because mice generation times are a few months or something like that. And so it's very well documented, very well studied in mice. Now, not everything that we study in mice translates. A lot of it does because we're all mammals, but a lot of it doesn't. We are beginning to put these pieces together in humans, and it seems like the same processes are there. But as you say, it's early days because, of course, to study humans, generation times are 20, 30 years. It takes a lot longer to get these kind of studies done.
Okay, so was I right when I said that any, experiences that my parents had up until the time I was conceived could be, markers that they had in there that they passed down, or is it really things that happened in their childhood that are more influential?
Oh, good question. No, it could be anything that happens right up to the time of conception, as far as we are aware.
I'm leading up to a bigger question here, but more influential, longer term chronic experiences, do those affect your epigenome more than what my, an argument my parents had?
Long-term chronic changes and the more severe changes are always going to have these bigger impacts than an argument your parents had or something like that, something short-term. Maybe less intuitive, maybe, it's just as important, is that early impacts can have bigger effects than later impacts because we're sort of we're more plastic. We're more responsive to our environments from sort of the time we're born, or even before we're born in the womb, up through our adulthood.
So it's almost like when we're little, we're like planets with no atmosphere, and everything that comes through space is pounding us. Whereas by the time we're adults,
Yeah,
we have a bit of an atmosphere that burns up most of the crap that's trying
I
to.
like that. I like that. Yeah, that's good.
Okay, so that suggests that the people who come from parents who've experienced extreme trauma or just chronic trauma, or there's a example in your book about, I think what is it called, the Dutch winter famine.
Yeah, the Dutch hunger winter. People call it different things, but the Dutch hunger winter, you'll hear it called if you want
Right.
to
And
Google it. It's amazing. Yeah.
so the children and even the grandchildren of people, of mothers who carried babies during the famine, there were distinct differences between those babies and their cohort, or their a different set of people. Can you describe what the results said?
Yeah, the way that plays out, what we notice is as they go from their 50s, 60s, 70s, and older, if their mother experienced this Dutch hunger winter, their risk of heart disease, diabetes, other kind of chronic diseases that we think of as being age-related, their risks are higher than kids that were born just a couple months before or a couple months after, so experienced very much the same childhood, but just didn't experience that. Their moms didn't go through that period of starvation. And then we can look at the grandkids of the mothers in the Dutch hunger winter. And like you say, again, their risks of being overweight, obese, are higher. So, that grandchild cohort isn't quite old enough yet to see a big uptick in things like heart disease because they just haven't aged into it quite yet. Mm-hmm. But they are on a trajectory that's a bit different than there are studies that other sort of cross-generation studies in humans that suggest fathers can have that same kind of impact, pass on that same kind of epigenetic information. We know, again, if we go back to mice work, we know that in mice absolutely that happens, that the dad's DNA gets marked with these epigenetic marks, and those can get passed on and have effects in the offspring. So it's not just mothers, but in humans it's best studied in mothers.
So that brings up to me the idea of, well, okay, I've got this book, as the metaphor you used, with all these flags in it that I didn't earn. My parents or my grandparents earned them, so to speak, because they experienced them, and now I have them in my genetic book. What can I do about it? What can I do other than just sort of try to deal with my hypertension or whatever it may be?
Yeah, so I mean, the answers are going to sound familiar, right? Healthy diet, exercise, those kind of lifestyle effects we know can actually affect those epigenetic marks. So it's hard to change all of them, all of those Post-its, Post-it notes in your book, but you can pull a few of them out. Remember, most of the Post-it notes you accumulate are of your own doing, right? They're happened as your own in your own lifetime. There are some interesting studies where people get assigned to a sort of healthy diet, healthy exercise regime, and it seems like they're pulling some of those epigenetic markers out of the book, so to speak. I don't think we know yet, sort of beyond this kind of healthy lifestyle effects that we'd expect from those kind of interventions, if the epigenetic effects are what's driving that or not. It's still early days for a lot of this stuff.
Okay. I want to keep asking you about this a little bit more, if you don't mind, because I mean, there's nobody who's not affected, who doesn't have marks in their genetic book from grandparents. I mean, the winter famine example and study was about a physical thing, starvation, that happened to the mothers. But what about, I'm thinking about war trauma. That may be somewhat physical, but also just psychological, cognitive drama, emotional drama. I guess the basic question is, how do emotional negative or positive experiences impact the epigenome of the kids and grandkids?
Yeah, so, in the case of the Dutch hunger winter, for example, I imagine that surely there was a huge psychological stress component to this as well. I mean, people were literally dying of starvation in the Netherlands at the time. I don't think we can separate out the physical from the psychological in that aspect. And so from that perspective, you'd say, well, yeah, it seems like the psychological can affect what's going on, because some of what we see with the Dutch hunger winter probably is the psychological stress and trauma of that. I know more broadly, people have looked at epigenetic impacts of just daily stress. So they look at people who are, for example, in the U.S., looking at minority populations. looking at people who are poor. And, there's a stress of living with that here in the U.S. And those are known to have epigenetic impacts. And so whether those get, how many of those and which ones get passed on, I don't think we know that answer yet. But yes, I can assume, based on what we know, that some of what's getting passed on is the psychological toll, not just the physical toll. We, or people in our community, are having this happen to them in a chronic way. This deprivation or the stress or the uncertainty that happens with, you name it, with war, with racism, with poverty. We know that affects the way our bodies work, including these epigenetic marks. We know that affects that, and we know it affects blood, even independently of the epigenetics. It affects blood pressure. It affects all these other aspects of our health. But your intuition is exactly right. These things are all cumulative, and so we have to be honest about that as we think about health and all these sort of long-term outcomes.
Herman, that leads me to my next question about DNA and destiny and how DNA is not your destiny. How is DNA not destiny when it comes to not just intelligence, but also, aging and the ability to age in a different way than our parents?
Think about it this way. Yes, I might know your DNA, and I might know all the variants you have, and I might predict, based on all your variants, that those are going to play out in a certain way, and you're going to end up a certain height, or a certain weight, or a certain IQ even, if all I know is your genes. And I might do slightly better than guessing. But what I will have missed as you grow old and you decide to start exercise and you change your diet, all of these things affect the way our genes turn on and off. Your genes are not just static. They're constantly dynamically turning on and off and affecting our traits, affecting your health, and the environment turns them on and off, right? So it isn't just nature or nurture. It's the way those things interact. And what that means, the upshot is, if I just know your genes, I'm not going to know your traits. I'm not going to know your height and your weight very well. Now, some traits, there's a closer match between your genetics and the outcome than others. So some things like the size and shape of your teeth, for example, right? Those are developed very largely due to genetics, and there's not a huge environmental influence on that.
I wrote about heritability recently in a post over the summer. A section of my post was because I'd read it in your book. So I wanted to ask you specifically, because it sounds like that's what we're talking about now. What is heritability exactly?
Yeah, so heritability it's that kind of thought experiment that we talked about a second ago. If I have your full list of genes, if I get Paul's full list of genes, I know every variant you have of your thousands of genes, how well can I predict your height? Right? Not knowing anything about your environment, not knowing anything about how you grew up or anything like that, how well can I predict your height, your weight, whatever? I could do a heritability for just about anything. The answer is, it depends. The other thing to understand is that the way we talk about this is we go from 0 to 100% or 0 to 1 with heritability. Either I am just guessing and I don't know anything about your trait based on your genes, that's a 0.
Yeah.
Or I can get your height to the quarter inch, right? That's 100%. I got it perfectly. And that's over a population of people, right? So I'm not just asking for you, I'm asking for 1,000 people. At about 50%, what you'd find if you had a heritability of like 0.5 or 50%, what you'd say is, well, yeah, it's pretty good. Tall parents seem to have tall kids, right? But we all know there's lots of exceptions. And we all know that a kid's not going to grow up to be exactly halfway between mom and dad's height. That's something like skin color. That is more heritable. If I know your genes that you have for skin color, I can tell it basically, because all I'm asking is how much melanin do your skin cells make. Something like heart disease risk, something like diabetes risk, something like IQ, for goodness sakes. Now you're talking about, well, okay, if I have 1,000 people and you're asking me to guess what their IQ is going to be based on their genes, yeah, okay, I can kind of, I've got something to go on, but I'm only going to explain 10% of the variation. My heritability is going to be 0.1, maybe 0.15. And what that looks like is, I can't really predict things very well at all. That's not to say that genes don't matter, right? Here's another thing about heritability. It's very specific to the population I look at. Mm-hmm. So imagine this thought experiment. I've got 1,000 kids, and I want to know how tall they're going to grow up. So I have all their DNA, and then I have in one experiment, I feed them all exactly the same food every day. They have exactly the same amount of exercise, exactly the same access to medicine, all that kind of stuff. Right? So I take the environment and I make it completely the same for all the kids as much as I can.
Mm-hmm.
Well, in that case, you can imagine the genetics is going to tell me more about the variability because those genes, whatever they were, for every kid interacted with the same environment. And so the environmental influence is going to be, it's important. It's important that I fed those kids. It's important that they got exercise. But because they all got the exact same food and the exact same exercise, there's no variation in that to sort of push some of them taller or some of them shorter. So in that case, the heritability is going to look pretty high. I'm going to be able to predict more from the genes. In a real world example, the kids are going home and getting fed whatever mom and dad feed them. Hopefully mom and dad are there. And there's all this variability environmentally. And so it's going to look, in the real world, it's going to be a smaller number of heritability because the genes are going to have a smaller influence because the environment's going to be so much more variable. Here's why I bring this up with longevity. By the time we think to worry about it in our 40s, 50s, and 60s, how much environment have we accumulated? How much environmental influence have we accumulated? And everybody's got a little bit different. And so, in that real world experiment that we're all living, the environment's going to have an outsized influence, compared to the most optimistic estimates from gene studies.
Herman, you spent quite a bit of time on the ground in northern Tanzania researching and living with, I think, the Hadza hunter-gatherer community.
Mm-hmm.
And in the book, Adaptable, you write about a surprising finding. Tell me if I got this wrong.